Since young Earth creationism is the specific type of creationism that denies the true age of the Earth and the universe, here's how we know that the Earth is 4.5 billion years old. In the next lecture, I will go over how we know that the universe is 14 billion years old. The reason I will give you the evidence for these two ages is that I want you all to understand that the skeptic is not emotionally attached to either of these ages. The skeptic did not assume these ages and scramble for evidence that supports these conclusions. No, the skeptic simply carried out the scientific method and discovered by pure chance that the Earth is 4.5 billion years old and the Earth is 14 billion years old. The skeptic does not care if the universe is 10 billion years old, or 100 billion years old, or even 100 trillion years old. It is simply just a coincidence that the universe is 14 billion years old, and anyone who says otherwise is factually incorrect. Likewise, the skeptic does not care about the age of the Earth, but simply accepts as a fact that the Earth is 4.5 billion years old. The method we used to figure out this age of the Earth is called radiometric dating. The two most popular forms of radiometric dating are carbon dating and uranium-lead dating. Let me first explain carbon dating. You see, a half-life is the amount of time that a radioactive atom spends having a 50% chance that it will decay. Regardless of whether the atom decays or not, the time before the final outcome counts as one half-life. This means that if you had 1,024 carbon atoms, each of them with a 50% chance of decaying, 512 of them will decay, while the other 512 will remain stable. One half-life has passed, but as soon as it is the case that 256 have decayed, while the other 256 have remained stable, another half-life will have passed. That's two half-lives. Clearly you can see that the more we divide the group of stable atoms by 2, the more half-lives we can measure. However, if we are able to measure, let's say, 10 half-lives, how long was each half-life? Now, a carbon atom typically has a half-life of 5,000 years. This means that if you had 1,024 carbon atoms, then you can do the math on a piece of paper or a whiteboard, like mine. So, as you can see, let's just make a chart that says half-lives and carbon atoms one half-life means that half of 1,024 carbon atoms have decayed. So that means that 2 half-lives shows us that half of 512 carbon atoms have decayed. And let's just keep going. 3 means half of 256. 4 means half of 128. 5 means half of 64. 6 means half of 32. 7 means half of 16. 8 means half of 8. 9 means half of 4. And 10 means half of 2. So you see, if we start off with 1,024 carbon atoms, and then 1 out of 2 carbon atoms decays, that means that 10 half-lives have passed. You can see that 1,024 carbon atoms provide us with 10 half-lives, and because each half-life is 5,000 years, Let's just multiply 5,000 by 10, and you get 50,000 years. Unfortunately, 1,024 appears to be the maximum number of carbon atoms that can exist in our specimens. That means that 50,000 years is the maximum limit of how far carbon dating can take us. Obviously, carbon dating would fail at telling us the age of the Earth, but at least the maximum limit of 50,000 years already disproves the young Earth creationist claim that the Earth is only 6,000 years old. With carbon dating as an unreliable measure for anything that's older than 50,000 years, we have to use uranium-lead dating. This is a form of radiometric dating that measures the half-life of uranium atoms that decay into lead atoms. Fortunately, specific isotopes of uranium atoms have half-lives ranging from millions to billions of years. For example, uranium-238 is an isotope of uranium that contains 92 protons, as every uranium atom does, as well as contains 238 neutrons, and this isotope has a half-life of, wait for it, 4.5 billion years. In order to measure just one half-life of a uranium-238 atom, you just need two of them. After 4.5 billion years, one atom of uranium-238 will decay into lead, while the other atom of uranium-238 will stay the same element. By finding hundreds or even thousands of materials that each have at least two atoms of uranium-238, we can calculate one half-life of 4.5 billion years. That is how we know the true age of the Earth. Join me for History 01 as I continue my series on a civilization that requires only carbon dating, not uranium-lead dating, for us to figure out its own older than 6,000 years age.